Okay, so I was asked to make a quick video showing how to deal with the regression that we just saw. So keep in mind as you deal with linear regression, quadratic regression, exponential regression, all of these behave exactly the same on our calculator. We just have one button that changes as we toggle from one to another. So we'll kind of go through that here very quickly. So when we look at our calculator, so let's see, I'm trying to find where my camera is. There it is. So my camera is sitting here on my calculator. And let's see if I can make this nice and big. So on my machine here, we usually start from our home screen. And when we have some data we want to put into, remember, we always go to stat. And from statistics, you can either edit your data or you could calculate various pieces of your data. I'm trying to make it not glare so bad. And so if you ever take the statistics class, this is the button where you get mean, median, and mode and standard deviation and things like that. This one has to do with when you have multiple variables, they call bivariable statistics, and we're not going to deal with that. This is a certain kind of regression that we're not going to deal with, but we've dealt with linear regression, and quadratic and cubic. So depending on what you believe your data to be, you can model it in these various places. So step number one, you go to stat and you go to edit, and then you put your data in. And I've already put some data in, and let me show you what that was, data up. So not exactly a pleasant topic, but the topic was, I was looking for a nice example, and I found some data that was back from the year 2020, kind of a bad time in many of our lives. Actually, that's the dates, or you'll notice, are written backwards from what we do. But this was February 23rd of 2020 and February 24th of 2020. And each day, what they were doing is they were logging the cumulative cases of COVID in the United Kingdom up to that point, because they were trying to figure out what was really happening. Okay, how virulent was it? How badly was it attacking the population of the UK? And the UK is a little bit easier to track than the United States because they're far smaller than we are. And so I felt like this was some pretty decent data to look at. So what I did is, although this data goes far beyond what I did, I just put first 20 days and thought that would be sufficient to get us an idea of what is actually happening. So step number one, I put my data in. We always do stat, edit. Again, stat. I go over to edit. I put my data in. It's critical that your two lists are exactly the same length. If they're ever out of length and you realize that one list is 1 unit longer than the other, your whole program will crash until you make sure they match. Now, just like always, we quit away from that place if we're going to go do something. So what I would like to do is, I believe everything that I've been told about viruses and everything is that they are exponential. I actually have not done this calculation yet. We're going to find out what happens. So I'm going to go to stat, and I'm going to go over to calculate. And I believe this data should not be linear or quadratic. I believe it should be exponential. Now, so if I click on exponential regression, I need to make sure in my head that I put my X list, my first list, the days, in list 1, and my Y list, my infections, in list 2, which I did. Now, this next part, often you don't have to do, but sometimes I like to do it, is I like to store that. So I'm going to go alpha trace, and I'm going to put that in Y1, because what I'd like to do is see how my model and my data actually line up. Does the curve go through the data? Do I have a nice visual? Now, as I go a little bit further down and hit calculate, it's going to go through all that stuff, and it's going to say, okay, so my initial condition was 10.3. 1.32. Now, if you look at it, the formula that I gave you was, let me just put this right here. Remember, the exponential story, anytime you have an exponential, it is y equals a times b to the x, right? But in the problems that I was talking about, This is 1 plus r to the t power. That's kind of how this is playing out. These are very, very similar. So what you could see is r in our case, since that entire thing is 1.32, it's growing at about 32% a day. Now, 32% would be amazing levels of growth in a year. This thing was growing 32% per day. You can see why people would have been very, very alarmed at the rate of growth of that thing. And it says that your initial condition was about 10.3. Well, if you look at my data, that actually lines up pretty well because it actually, the first case to date, let me go back to that. Let's go back to this so you can see it. There it is. But my first case, it was 10. But keep in mind, it's coming up with the best equation that I didn't hit share, sorry. It's trying to make it fit this data, and it didn't hit 10, it hit 10.3 because that was the best one that goes through it. Now, let's go ahead and try to get back to our calculator and see what happens. So what we can do now is, now that we have our data in here, we have calculated it. What we can do is we can hit the zoom button and we can hit 9, which is statistics, but I just remembered something that I had not done. So if I hit zoom 9, somebody was telling me their calculator wasn't working, and that happened for me here because I forgot under y equals, I forgot to let the calculator take a look at my data. So I'm going to turn my plots on so I can see my data. And then again, I go to zoom 9, that's zoom statistics. And so I can see how this model appears to really hit my data quite well. Now, you'd realize it's not perfect because this is real life data. And real life data isn't clean and nice like it would be in a model. It's real. In some places, the curve is less than the number of cases. In some cases, the curve is above the number of cases, but it splits the data quite well. In fact, according to this, ridiculously well, because we went to stat calc. Let's go, it was a number I thought it was going to be, but I've done too many things in the meantime. Boom. Let's go back here and calculate it. My correlation coefficient is 0.997, which means it's very, very close to 1. It's a very strong correlation. So we would be able to use this to predict all sorts of things. So I could ask a question. For example, I could say, when will there be 50,000 cases? Well, for obviously, if you think about that, 50,000 cases would be a scary number that would really overwhelm the number of hospitals that you have. We know that that happened. So we go to y equals and we put in 50,000. Now I do have to make a little bit of a guess because I don't know how long that's going to take to do. I think I did 500,000. Let me double check that. Yeah. So I want to know, when is it 50,000? That would be a pretty alarming number considering what we're looking at, but I don't think it's going to take us very long. So clearly, if I want to go to 50,000, I'll let it go a little higher, like maybe 60,000. And let's just go ahead and let time run, because in 20 days, it went from 10 cases or 11 cases. In 20 days, it went to about 3,000. So I'm fearful that it's going to go pretty fast. So I'm just going to give it about 50 days because I think that's plenty. And so let's see. Did it happen within the first 50 days? Oh, yes, it did, in fact, quite quickly. And so we could calculate the intersection. So the hospitals in the United Kingdom ended up finding that that happened, according to my model, at about day 30. I got day 30. And by the way, now again, all I did is I took a look at the first 20 days that were publicized. But let's go ahead and see what happens if we actually look back at the data that they gave us. So if they started recording it on the 23rd, roughly 30 days later would be around the same time in the following month. And so if I go to the 23rd of the next month, somewhere around there. Where would that be? Oh, I didn't quite get there, but we're sitting at already 10,000. So again, I said 50,000, so maybe my model was a little bit hot for what they had, but you can see we've definitely gotten into some pretty serious numbers pretty quickly. I thought it would be a little more accurate than that, to be honest, but that's how regression is. Sometimes it changes over time and our model loses accuracy. Now, the other thing that I was going to mention before we leave this is how do you handle your calculator if something isn't right? So frequently people will have the issue where their calculator's not telling them some of the things they want them to tell them. And so under mode, there's a lot of things that are there. So sometimes if your calculator is not being cooperative, look at your mode. And generally speaking, the left side should be highlighted, but if you follow it down to this spot right here, notice it says stat diagnostics right up here. Your stat diagnostics should be on, and if it's off, it's not going to give you that R value. But if it's on, it will. Okay, that's pretty easy. Also, if you're looking at it and it's not giving you the some like axis or something like that, as it turns out, there's a format button above Zoom. That's another place where things get kind of wonky sometimes. So this is about how it should be set up. You should be in rectangular, not polar. That's for later. You probably want your coordinates on. You probably don't want grids because you'd see lots of little dots all over the place on your screen, which would be a little strange. And if somebody has ever turned on like a water fountain or some silly thing on there, right down here, you can see it says background and you can turn those background images off. And so that kind of tells you a little bit. And notice mine is set to detect asymptotes, which is kind of nice. So it'll show an asymptote if it believes that there is one. And if it doesn't believe there is one, it won't bother to do that. But it's set almost like an AI situation, trying to find those things for us. So hopefully that is helpful. Yeah, I will see you guys back in class soon. All right, bye-bye.